Hello everyone. In this video, I'm going to explain you the software design strategies. Software design strategy is mainly about organizing design activity during the course of the design. The software design is the process to conceptualize the software requirement into software implementation. A software design takes the user requirement as challenges and tries to find the optimum solution. While the software is being conceptualized, a plan is chalked out to find the best possible design for implementing the intended solution. The organization of the design activity, be it planned or ad hoc, reflect a designer's approach to creating a design. A good software or a system design is to be organized the program modules in a such a way that are easy to develop and change. Whenever user wants any kind of changes, the good software or a system design which organize the programs in a modular format, so the modules are arranged in a such a way that one module can be changed for the user requirements, cannot affect the other module. A structured design technique helps the developers to deal with the size and complexity of the programs. And also, the analyst creates the instruction for the developer about how code should be written and how the pieces of code should fit together to form a program. There are multiple variants of software design. So there are three variants of software design. Number one is the structure design. Number two is the function oriented design. And the third is the object oriented design. In the structured design, the structured design is the conceptualization of the problem into several well-organized elements of solution. It is basically concerned with the solution design. And also, benefit of the structured design is it gives the better understanding of how the problem is being solved. It means the structured design gives us the structured format to understand the problem, to better understanding of the problem, to solve it in a particular manner or step by step manner, how the problem should be solved. That structure is illustrated in the structured design so that we can solve the problem in a better manner. So therefore, the structured design also makes it simpler for the designer to concentrate on the problem more accurately, because the structured design is unintentionally classified on the basis of divide and conquer strategy, where a problem is broken into several small problems and each small problem is individually solved until the whole problem is solved. That is the use of the structure design. And also, the small pieces of problems are always very easy to solve. So those small pieces of problems are called as solution modules, and structured design emphasizes that these modules be well organized in order to achieve the precise solution. And these modules are arranged in a hierarchical manner so that they can communicate with each other. A good structured design always follows some of the communication rules among the multiple modules. For example, cohesion, it is a grouping of all the functionalities related to the elements which belongs to a module, whereas the coupling is used to communicate between the different modules, or it used to have the communication between the different modules. And always we say that the good structured design has always a high cohesion and low coupling arrangements. The second strategy is the function-oriented strategy of the software design, where the function-oriented design, the system is comprised of many smaller subsystems known as functions. These functions are capable of performing significant tasks in the system. The system is considered as a top view of all function. So the system is the top view of all the functions. So all the functions are included into the system because the system is divided into the smaller subsystems which are known as functions. And function oriented design inherits some of the properties from a structured design where the divide and conquer methodology is used. And this function-oriented design mechanism divides the whole system into smaller functions, which provides the mean of abstraction by concealing the information and their operations. These functional modules can share the information among themselves by mean of information passing, or we can say the message passing, and using the information available globally. So some of the design notations we primarily used during the process of the designing and are used to represent the design or the design decisions. For function oriented design, the design can be represented either graphically or mathematically with the help of the following design notations. Here in this design notations, we have data flow diagrams, data dictionaries, structured charts, and pseudocodes. Because function design is a paradigm used to simplify the design of hardware and software devices, such as computer software and increasingly 3D models. Okay, and also it assures that each modular part of a device has only one possibility and performs that responsibility with the minimum of side effect on the other parts. So we use these design notations. Say the first one, the data flow diagram. So data flow diagram is concerned with the designing a series of functional transformations that converts a system input into required output, and the design is described as a data flow diagrams. So these data flow diagrams shows how the data flows throughout the system from one module to another module, how it is flowing from one part of the system to other part, and how the output is derived from the input throughout a series of functional transformations. These are the some of the notations which we used in the DFD. The rounded rectangular which represents the functions which transfer the input to output, and rectangular which represents the data stores, whereas the circle which represents the user interaction with the system which provides the input or which receives the output, and arrow which shows the direction of the data flow, how the data is flowing and where it is flowing, from which part to which part of the system it is flowing. It shows the direction of the flow of the data. And also the keyword and or, these have their usual meaning in Boolean expressions. They are used to link the data flow when uh, when more than one data flow may be input or output from a transformation. So this is the example of the data flow diagram of a design report generator. So when you design a report generator, so how your data flows. So as illustrated here, the circle is the input. So we are inputting the data here for generating the report. And when this particular rounded rectangular gets the design name, and then designs the names and get entity names. So get entity names are getting from the design database. So the rectangular is represented by the data stores. So design database and data dictionary are the data stores. And you can see the arrow marks which shows how the data is flowing into report generator. And finally report print, and then the output is generated. Okay, so this is how you can retrieve the information about the each name which you enter into the system with the help of get entity names with the design database. Okay, and data dictionary. The report generator finds the names used in the data flow diagram. It looks up the data dictionary and retrieves the information about each names. This is then collated into the report which is output by the system. Data dictionaries. The data dictionary is a collection of names, definitions, and attributes about the data elements that are being used or captured in a database, information system, or a part of a research product. Here, the data dictionary lists all the objectives of all uh, the data items and the definition of all composite data elements in terms of their component data items. For example, a data dictionary entry may contain that the data gross pay consists of the part regular pay and overtime pay. For the smallest unit of the data element of the data dictionary, list their names and their types. So also the data dictionary plays a significant role in any software development process because of the following reason. The first is the data dictionary provides a standard language for all relevant information for use by engineers working in a project. And also the data dictionary provides the analyst with the means to determine the definition of the various data structures in terms of their component elements. And different engineers of the project tend to use the different term to refer to the same data, which is unnecessarily causing confusion. So this is how this data dictionary is used in the software designing to give the attributes about the data, and it tells about the data which we are using in our software. Like gross pay equals to regular pay plus overtime. The next is the structured chart. The structured chart, it partitions a system into block boxes. A black box system that functionality is known to the user without the knowledge of the internal design. For example, these rectangular represents the modules, and the arrow shows the data flow as well as the control flow or the control flag. So this is the hierarchical format of a structure chart of the system. A structure chart is a graphical representation which has a set of symbols, like rectangular represents the module, arrow shows the flow, and arrow with the circle shows the data couple, and arrow with the filled color or a circle shows the control flag, and arrow uh, with the rounded arrow which shows the loop, and diamond symbol shows the decision, which is the system partitions into modules. So we can represent our system in a structured chart. In a number of modules can be represented in the structured chart, so that hierarchy of components of the modules and their relationship between the processing modules, interaction between modules, and information passing between modules can be shown. So this is how we can use this structure chart to represent the overall system or the overall system design into structured chart. The next, the fourth one is pseudocode. Pseudocode notations can be used in both the primary and detailed design phases. Using pseudocode, the designer describes the system characteristics using short, concise, and English language phrases that they are structured by keywords such as if then else, while do, and end. So these kinds of words, phrases are used to represent the pseudocode, and it is very useful for both the preliminary and detailed design phases. So the analyst will mention in the SRS document. So after completion of the function-oriented design, the third strategy which we follow is the object-oriented design, which works around the entities and their characteristics instead of the functions involved in the software system. This design strategy focuses on the entities and its characteristics rather than the function and the structure. The whole concept of the software solution revolves around the engaged entity and its characteristics. Now let us understand some of the important concepts of the object-oriented design, like object, classes, message, abstraction, encapsulation, inheritance, and polymorphism. Object. All the entities involved in the solution designs are known as objects. For example, a person, banks, company, and users are considered as objects. Every entity has some attributes associated with it, has some methods to perform on the attributes. Similarly, we have the classes. It is a generalized description of the object. Object is an instance of a class, and a class defines all the attributes which an object can have and the methods which represents the functionality of the objects. Message. Messages are used to communicate with the objects, or we can say object communicate by message passing. Message consists of the integrity of the target object, the name of the requested operation, and any other action needed to perform the function. Message are often implemented as procedure or a function call. Similarly, the abstraction in object-oriented design reduces the complexity, and it handled using the abstractions. Abstraction is the removal of the irrelevant and implied data from the structure, from the design. Encapsulation. Encapsulation is also called an information hiding concept. Why it is called the information hiding concept? Because the data and operations are linked to a single unit. Encapsulation not only bundles the essential information of an object together, but also restrict the access to the data and methods from the outside world. The next is the inheritance. The inheritance is the concept where we are acquiring the property of one class to another polymorphism class, which allows a single interface performs a different types of operations depending upon the how the service is invoked. The next is the software design approaches. There are two generic approaches for the software designing. Number one is the top down, second is the bottom up design. Top down design. We know that a system is composed of more than one subsystem and it contains a number of components. Further, these subsystems and components may have their one set of subsystem and components and creates the hierarchical structure in a system. Always, this top down design strategy starts with a generalized model of a system and keeps on defining a more specific part of it. When all components are composed, the whole system comes into existence. The top down design takes the whole system as one entity and then decomposes it. Second is the bottom up design. The bottom up design model starts with the most specific and basic components. It proceeds with the composing higher level components by using the basic or lower level components. It keeps creating higher level components until the desired system is not evolved as a single component. Bottom up strategy is more suitable when a system needs to be created from some existing system where the basic primitives can be used in the newer system. Both the top down and bottom up approaches are not practically individual. Instead, a good combination of both is used. So, thank you for watching. Kindly like, share, and subscribe.